हेलो आई नो यार ऑलरेडी बहुत लेट हो चुका है इसलिए आई स्टार्टेड बिफोर टाइम I know. Firstly, just let me know that how many questions you guys did. Oh God, today's contest. Oh my God, fourth question. Yaar, the intuition for that nil. Like especially what data structure is going to be applied. Damn. Firstly, just make sure that okay, I am audible and whosoever is in, can we please whoever is live, just write down below, like whoever is there, like is my audio video good? I know my camera wires are all wrinkled together, whatever that word is, but yeah, we'll not waste any time. Hello 50 GB. Hello Bennett, let's go, yeah, correct. Chiru, hi bhaiya, hi. Poker face, Leetcode third had me in tears. Yeah, that's true. Third and fourth one both were oof. Two only, sorry, no worries. Anish, two. Shivam, good. Bhaiya, third, fourth question, OP. Yep, true. We'll not waste any time. We will not waste any time at all. We'll quickly jump on to every question. First and second, we'll quickly have it done. Please do the standard ritual. Meanwhile, liking it, please. I know it's already late, so we will actually do it very quickly. Firstly, account balance, all rounded purchases. It just says you have $100 and a few things happening that okay, the purchase amount representing the amount you will spend on the purchase in dollars. We have this purchase amount with you, but what you have to do is you have to subtract this purchase amount, round it off to the nearest 10, which means a multiple of 10. And when you have to round it off, you have to make sure that okay, if the number is 5, it will round off to 10. If the number is 4, it will round off to 0, which means if the number is 5 or less, which means if the remainder, which means whatsoever is remaining, if it is 6, 7, 8 or 9, it will be rounded off to higher 10, and if it is less than, which means 1, 2, 3 or 4, it will be rounded off to lower 10, which means lower multiple of 10. So that is if we will, like, what we will do is we'll just make sure okay, whatsoever number we are choosing, whatsoever purchase amount we have, we will just, let's say it is 15, so it needs to go to higher multiple of 10, that is it will go to 20. So we have to subtract 100 minus 20, we will get a simple 80. Simple. You can also have this in one liner, just saying that okay, 100 minus whatsoever purchase amount you have, add a 5, so that you will actually go on to the, because see, if the number is 15, 16, 17, 18, 19, right, or even 20, so what you want is all these numbers should turn back to 20, right? And all the numbers which are 14, 13, 12, 11 and 10, they should not become 20. So what I will do is I will just simply say okay, I can simply add a 5 to that number, and that number, let's say the number is 16 plus 5, it will actually become a 21, right? So if that becomes a 21, I can simply say okay, now the number has become a multiple, like it has exceeded to 20, so I just need to get this 2, because ultimately for this 21 number I need to only get a 2, so that I can know okay, I have to bring it back to 20, because I want the next multiple of 10, which is actually a 20. So I will just simply can push it back, and then I can simply okay, now the number is 2, I will multiply by 10 because it's actually the multiple which I wanted. I can simply get this done. It's a one liner, but if you don't want to get into all such that, you can simply any way you can do it, any way whatsoever you want. You can simply get the remainder, then you know okay, what is the remainder, which is actually okay, you have the starting remainder, you have the ending remainder, which means you have this number, let's say 16, you know the starting remainder is 6, ending remainder is 4, right? Now you know okay, the starting remainder is less, which means okay, if the number is 12, right, starting remainder is 2, ending remainder is 8, right? So you know okay, 2 is less than 8, for sure you have to bring it to the smaller 10, which means smaller multiple of 10. So you can just bring it to a smaller multiple of 10. But if it is actually more, which means okay, if it is 16, so if it is 6, it is 4, which means it actually needs to go to a higher multiple of 10. So simply subtract the higher multiple of 10. That's how you can simply solve it. There are many ways to solve it in one line. You can choose any way whatsoever you want. It is just that you just have to make sure okay, if the number is 5 or more, please, like when I say 5, I mean a 25, a 35, and so on and so forth. If the number is 5 or more, please push it to a higher multiple of 10. And if it is less, which means 1, 2, 3, or 4, please push it to a lower multiple of 10. That's pretty much it for the first question. We'll quickly jump on to question number 2. This also I highly recommend. If it is in a contest, you will simply convert this IST any way whatsoever you want. If the problem is of contest, just figure out any way you can solve it. There is not required, like it's not required to actually solve it by some space optimization, some optimization in time. If it is saying for time optimization, which means if the constraints are not in your favor, only then optimize time, else simply do whatsoever you want. The problem just simply says, and firstly, meanwhile, please, if you're watching it, we'll all see all 4 questions. No, it's pretty hard, and although we are already pretty late, but yeah, we will try to make sure that we wrap it up on time. But for that, I need your help. Please like the video as whatsoever you want, and for sure we'll also read the comment, so that okay, we are not hurrying up and we are addressing all the comments, right? But if for the first question there is no comments as such, so we'll actually look on to comments later. If after we have done the second question, right? Insert greatest common divisor in the linked list. It just says that okay, I have a linked list, and what I have to do is, okay, for these 2 numbers, whatsoever is the GCD, I need to insert that between these 2 numbers. For 18, 16, the GCD is 6, I will insert that. For 6 and 10, the GCD is 2, I will insert that. For a number 10 and 3, the GCD is 1, I will insert that. And that we have to do for the entire linked list. Now, simple, if you don't have to apply the brains, simply what you can do is simply convert this linked list into a vector. Okay, I have got a vector as 18, 6, 10, and 3. If you're not applying any brains at all, convert this to a vector, which means simply use a head pointer, any pointer temp, simply iterate on this linked list. You know how to iterate on a linked list. If not, then simply go and watch a linked list video, you will simply get it done. But if not, then okay, simply get this in a vector. Now if you have this in a vector, simply compare I and I plus 1, get the GCD by simple function of GCD underscore GCD of 2 numbers, I and I plus 1. Or basically if you have I, then you can also have a I and I minus 1, anyway whatever you want. Now you have the GCD. You will simply make on a new linked list by simply saying, okay, push in the first element, push in the GCD, push in the next element. Then whatsoever like loop you can have or perform, simply if you're landing at the first element, just ask, okay, if the first element is this, okay, I will just insert my first element as a new node in my linked list. Okay, I will also insert the GCD as a new node in my linked list. Then again my loop will go on, which will insert the next element, and again it's GCD with the next number, and so on and so forth. It is one such way which is not at all space optimized, but if it is fast for you, you can simply perform that in a contest. But for sure, we know a bit linked list. We have completed a linked list quite a lot. We know that okay, we can just simply, what we can do is we can have a pointer here, and we know okay, the next pointer, let's say the pointer is temp. Initially it is pointing to head. I know it is temp next. I can easily find the GCD. It will be nothing but underscore GCD of temp value and temp next value, right? It is the GCD. Now I know that okay, I know okay, I will get the value. Let's say the value val, right? Let's say name it as a simple GCD, like int GCD. I got the value. Now I know I need to insert this between temp and temp next. So what I will do is I'll take another node. For sure it is a new node which I'm inserting, so I have to make this new node. So what I can do is I can make a new node by simply saying list node star, and let's say new node equal to new list node, and then giving the value which is this GCD. Okay, now the new node is made. Now my task is to insert this new node between these 2 nodes. Now when I mean to insert, I mean this temp next, it should become equal to new node, and new nodes next, it should become equal to the next of temp. So Firstly, if I know, okay, for this node 18, its next is 16. If I will directly apply this 18's next to new node, so I will lose this connection. So I want, okay, new nodes next should be equal to 6. So what I will do is, firstly, I will just make sure, okay, new nodes, which is the node which I have made, okay, new node, let's make it up, new node, I will say new nodes next will actually be equal to this temp next, right? It is equal to this temp next. Okay, now this connection is made. Still this connection is there, right? No worries. Okay, now I know, okay, my new nodes next is equal to my temp next. Okay, the connection is made. Now make sure, okay, the temp next, it should point to the new node. So I'll just say my temp next, it should point to the new node. And that's how, by simply iterating on your temp, or basically saying while simply iterating on your temp next, because you need to make sure that for every temp you are having a temp next, because you are doing a GCD of temp and temp next values, right? So make sure that you are having temp next with you, right? So what I will do is, I will just have a while loop. While my temp next is not equal to null, I will simply go and apply operation, which means find the GCD, make a new node, then apply new nodes next as temp next, and then when I have applied the next of new node, then only I will just say temp next will actually be a new node. And by this, I will simply iterate on this entire linked list and will only make this new nodes, and I can simply build my answer. It is also very simple, but yeah, again, it is a contest. So whatsoever seems feasible to you, if it is feeling okay, I'll simply make a link. I will simply make a vector, new vector. I'll simply make the entire linked list. No worries, you can do that as well. Cool. What I do is simply getting a PTR as a head. Now, if this PTR is, while this PTR next is there with me, what I can do is I can make a temporary node. Again, I can make this node, but this node is the GCD node which I have made. It is the GCD node having the GCD of PTR and PTR next. Having PTR and PTR next, I have this now. Okay, it is the GCD. It is a new node which I have made, which is temp. The new nodes next, I will point it as the existing next which I had, and then when I have marked my new nodes next, I will simply say, okay, PTR next will actually become a temp, by simply saying, okay, now my the next value which I need to have for this PTR, it will be actually be the new node which I have made, which is a temp, and simply I will just simply keep on moving. So I need to make my PTR as temp next, so that I can actually move on to the next PTR, because I am simply going on to the next PTR, next PTR, next PTR, next PTR, and so on and so forth. Ultimately, I'll simply return the head, because it was actually pointing to the same head which I had in the very beginning, because I did not change the head. I'm using the existing head itself, which is pointing to 18 itself. Cool. We'll quickly jump on to question number 3, but before that, we will see the comments quickly. But before that, you know the ritual. I know the ritual. Please like the video. At least reach 50 likes. That would be super great. We will not stress on that today, because for sure we are a bit late. But yeah, we'll actually took it. The questions, the specific, comments quickly. Too only sorry, too good भैया, third fourth question OP everything good. चलिए शुरू करते हैं ग्राफ कंटिन्यू करो भाई प्लीज. फॉर श्योर आई ट्राई टू ब्रिंग इट टुमारो. आर्यन भाई मैंने 3 सॉल्व किए, थैंक्स टू यू एंड योर लाइव डिस्कशन. थैंक यू सो मच कृष्णा. नमस्ते. दो हु एल्स ट्राई टू सॉल्व थर्ड यूजिंग बाइनरी सर्च? दैट you can solve, but if you even think of binary search, then okay, you know the binary search is going to be applied, but still, on what condition you will think of, okay, binary search is there, now what, after then what, right? Which means you have the condition, okay, you will just simply do a binary search on, let's say, the number of maximum number of, what was the question? Maximum number of seconds. You can do a binary search on that. But when you are saying, okay, I can try in for 3 seconds, still it's just a log-in operation more, because you know that you will be able to do in 3 seconds if you know, okay, that adjacent difference is actually 3 or less. Cool. So basically binary search is more of an extra step. on top of what we existingly can have, because in a Bayesian search, if you know, there's a is possible condition, right? So that is possible condition, is more than enough to solve this problem, right? Cool. कौन all किया है हाथ उठाओ. That would be hard because fourth question was actually hard. भाई आता हूँ स्ट्रीम देखने, वैलोरेंट का मैच चल रहा है बस. No worries, Shivam Negi. Last two can't solve. Trying for the past 3 months. No worries. It will actually Adam already liked. We have a contest tomorrow. Yep, we have. Me solved 3 after months. Haha. That will actually add up. Bro, I was waiting for your live. Then we'll go to sleep, buddy. Cool. I did in place. Cool. Simply by traversing PDNX. Correct. I did only add node list with GCD. True. 2-point approach. True, bro. Go to fourth one, please. Yeah, we will actually go. Me 2.2k. Me 1167, fourth done, return head. Cool, bro. I'm having a way of question of Google sprinkler ventilation of this year. Can you make a video of these questions? Cool, you can share that in the Telegram of Telegram channel. Nope, only 3 questions I can make. Good. I took okay, I tried BFS with the source as maximum frequency. Me to BFS लगाने लगा था. 3rd में TLE 2 ही किया है bro. Yes, Bayesian search मैंने भी सोचा था, but उसके बाद कैसे सोचा? 3rd and 4th, so almost 3rd one बस stuck due to rotated. Cool. Now coming back to the 4th question. Meanwhile, I know. Let's have the quick standard ritual going on. Minimum seconds to equalize a circular array. For sure, if you know, I know. If we have a circular array, we know, okay, the array will repeat itself. For the repeating part, we can actually add the same array again. Or what we can do is whatsoever is impacting for a repeated array, we can add that factor again. Which what I mean by that is, if you know 1, 2, let's say 3, 4, 5, 6, it is an array. Now you know it's a circular array, which means it is repeating. So what we can do is we can simply write the same stuff down again, which means we can simply write the same stuff down, which means 3, 4, 5, 6 again we can write down after this particular vector. Or what we can do is we can simply know, okay, if I know after my 6 I have the next element as 3, which is impacting, which means because ultimately I will be using these all 4 elements, so whatsoever is impacting me I can only add that as well anyways, which means if I know, okay, I'm only concerned about the location of these, let's say for this 5 I'm concerned about the location of this, and maybe I'm concerned about, okay, after this 5 let's say a 3 comes in, I'm concerned about that 3, but I'm not concerned about, okay, if that 5 is there then I have to have a 3. I'm only concerned about after 5 if I have a 3, so what is the location of that 3? So I can easily know, okay, the location of 3 is, let's say, at index 0. So for sure we know we have 4 elements, so the next location of 3 will actually be at index 4 itself. So we can easily say by simply adding a size of this entire stuff, by simply adding that in the index, and can simply say at location 4 I will imagine. It's not necessary to make the entire array again. I can simply imagine that, okay, at index 4 I can repeat the same element 3 again. So if I'm only concerned about the concept or the indexes or anything like that, I can simply imagine, okay, I have the index at index 0, I have 3. If I add the size in my actual index, so I will just simply repeat that again in the next part. So that's the main concept of making that circular. But I'll highly suggest that if it's a starting for you and you encounter this circular array bit, then please make sure that, okay, you just repeat the entire array and append that entire array again after your main array. If you had an array 3, 4, 5, 6, you can simply append 3, 4, 5, 6 again on this back of the entire array. With this, it will just make sure that, okay, you have the index 4, 5, 6 and 7. And if you are not concerned about appending the entire array again, you can simply add the existing indexes, you can simply add the size to get the new index of that array, of that element, which means for 5 the new index will be 2 plus 4, which actually is 6, and you can see that here as well. At 6 index I have the element as 5. Cool. Now it is a one such part of, as soon as you read the word circular array, you know what you have to do, or it is a standard concept which actually be applied in a circular array. Now going back to the questions itself, now as we have the questions with us, we know, okay, we are having a zero indexed array called as nums containing n integers. Now, cool. Simple saying, okay, I have an array nums and having n integers. Now, at each second, you can perform the following operations on the array. For every index I, what I can do is I can replace the nums of I, which means the element at nums of I, with nums of I, or nums of I minus 1 plus n mod n. You can simply imagine this as nums of I minus 1 itself. Now, how I did that? I can simply say that, okay, I can just break this down into I minus 1 mod n plus n mod n. N mod n is simply a 0. So I can simply say, okay, it is I minus 1 mod n, which is actually saying for index I, which means the element at index I can simply replace that element at index I by element at index I minus 1 or element at index I plus 1. Which actually means if I have an array of, let's say, these 5 elements, I can replace this element I with actually I minus 1th element or I plus 1th element. Now you will ask me, then Aryan, why is this plus n is given to us? Plus n is given to us. Now it is only given that, okay, if the element is actually a starting element, then the previous element I minus 1, which means 0 minus 1, will be nothing. So it actually represents a circular array. So that minus 1 will actually say this previous element. When I say previous, it will actually go and point to the first element, which means, sorry, the last element. Now for this, again, the I plus 1 is this. Now again, is if I am taking this last element, the I plus 1 for that mod n will actually point to the starting index, which is this, the index 0. That's the reason it just says how to actually read these indexes. So for the index I can simply replace this with I plus 1, or I can simply make it as I, or I can simply replace this with I minus 1. That is the 3 options I can replace an element to. Now going on further, note that all the elements get replaced simultaneously, which means if I have this array and I choose to replace some elements, I can replace some elements simultaneously. And it is not that, okay, I will replace one element then other element at a time t equal to 1. At the time t equal to 1, I can replace all the elements I want simultaneously. So that will be done at time t equal to 1. Now cool, I have this thing done with me. Now return the minimum number of seconds needed to make all the elements in the array nums equal. Now ultimately my task is to make all the elements of this nums as equal. Now ultimately, for sure, one thing is for sure, if I want to make every element of this array equal, then for sure it will be one of these elements only. So if I want to make it equal, either it will be a 1 or it will be a 2, right? So for sure, if I let's imagine I want to make it equal to a 1. So what I can do is I have a 1 2 1 2, right? If I want to make it equal to a 1, so I will just replace this 2 by 1, okay, because it is the adjacent element is 1, and also I can replace this 2 by 1 by simply saying, okay, at time t equal to 1, I replaced all the elements and all the elements become same. Cool. So it can be answer, and it's actually an answer. Okay, what if I replace all the elements by 2? No worries, I can replace it. So if I just replace this element by 2, okay, replaced. If I replace the element by 2, okay, replaced. Cool. At time t equal to 1, I replaced all the elements by 2. What if I look at the next example? Okay, let's imagine I replaced all the elements by 2. So if I just wanting, let's say if I just wanting all the elements to be replaced by 2, so what I can do is, okay, replace this by 2, okay, replace this by 2, okay. At time t equal to 1, all the elements which I could have replaced by 2, I replaced that, okay. Now at time t equal to 2, because still all the elements are not equal yet, so again I can actually replace elements. So I just simply can replace this with this 2 or this 2, any 2 I want, so it will simply again become a 2. Okay, at time t equal to 2, I can actually get all the elements same or equal. Now for sure, the first thing which comes in our mind is, okay, how can we solve it? Now again, first thing which comes in our mind is greedy, that okay, what if I have the maximum frequency element, which means what if I had a 333 in the maximum frequency, then I could have replaced that. For sure, it comes in our mind is, okay, I have a 333 as the maximum frequency number, and I have a 22. It's always beneficial that I will just simply replace the existing numbers which are not in the maximum frequency with the number which are actually in the maximum frequency. And it actually makes sense also. Okay, it can be possible. Okay, we have many numbers and we have to make all the numbers equal, so please bring out every number equal to the maximum frequency number. But hold on, whenever we say a term greedy, please make sure that either you validate that is correct or you validate that is wrong. If any ways you can prove it that your greedy is not wrong, or basically you can prove it your greedy is correct, that it's actually gonna work. But proving a greedy is correct is actually hard, so you have to make sure that you build a counter example that greedy is wrong. Now, as I showed you, okay, I have the maximum frequency element, so it can be done. But let's say, what if I don't have maximum frequency element? And it's actually visible in this question itself. Here, the maximum frequency element is both 2 and 3. Then, in such kind of cases, what you will take? You will take a 2 or you will take a 3? That will be a doubt, because you can take either a 2 or a 3. Anyway, anyone could work. So now you are stuck. In the example itself, you are stuck because you know the frequency of 2 is also 2, the frequency of 3 is also 2. So both are maximum frequency element. Now which element you will take? Oh yeah, Aryan, what I will do is I will take the whatsoever occur first, which means 2 became the maximum frequency element as first, so I'll take 2. But what if I say you the question was, let's say, now okay Aryan, what if I just say that if I even take a 3, still I can complete this in 2 steps. Let's see, if I took a 3, okay, it will become a 3. It will become a 3. Okay, here it become a 3, here it become a 3, and in the step 2, which means at the time 2, again this element, it can become a 3. Aryan, see, if I take a maximum frequency element, no matter if both are same, I can still make my time as in the minimum time, because I am only concerned about the time, right? So what if I take a 2 or a 3? No matter, I'll take a 2, and by this also I'm getting a 2 as a minimum time. If I take a 3, I'm still getting a 2 as a minimum time. So for sure, I'll take a maximum frequency element. Hold on. You took this example. Now try to build any other example such that your maximum frequency element is not going to bring you the maximum answer. And with this, for sure, what you can do is just make sure, okay, you have the maximum frequency element at one side, then you have some, that's the reason. See, how you were able to think that greedy would work, you have to just say, okay, that would not work for me. What you can do is just try to build a counter example that, okay, having a maximum frequency element would not work. Now we know, okay, the better example, it was given by the question itself. I can have 2 such elements have the same frequency and both will have a maximum frequency. So I'll just take 2 elements have the same frequency, and with that we will try to build, if we choose that, okay, one element rather than other, we're actually building an answer in the shorter time. So what we would like to do is, we would like to build an example such that greedy would not work. For that, let's have any such example. Same, okay, I will have maximum frequency element. Let's say maximum frequency has 2 itself. Cool. So I just want 2 elements to be placed. I'll place these two elements consecutively. Okay, let's say I place a 2 here. Then I'll place same frequency element again, which means let's say I place a 3, but here I will leave a space so that I know I can build my example better with the next frequency number, because I know both 2 and 3 will have frequency as 2, but I also want in my mind with 3 I should be able to build my example faster, which means my answer should be able to complete in just 1 second, and I will just try to build an example by that, which means in a smaller time I should be able to build the answer. So I have a 3, I will leave a space for some other random element, and I'll again place a 3. Now what I tried to build was, I tried to place some elements consecutively which are having a maximum frequency, and some element a bit far apart to have the maximum frequency. And now I'm just trying to build an example such that, okay, now let's place any other element having frequency other than 2 and 3, which means having number other than 2 and 3. Let's say imagine as 9. Now we have the best example. if I have to choose a 2 as a number which I have to make ultimately in the end, what I would be doing is I would be simply taking it as 2 2. Okay, it's a bit more bigger. I will simply be saying, okay, 2 2 3 9 and 3. Now to make it as all 2s, I will simply replace this by 2. Okay, 2. Simply replace this by 2. Okay, 2. In time 1 I could only replace these two. Again in time 2 I'll actually replace this by 2 also. Okay, so to make all the 2s it took 2 seconds, while if I would be able to choose a 3. Let's say if I'm saying, okay, let's make all the element equal to 3. So what I could have done is, okay, make this a 3, make this a 3, make this a 3 also. So in time 1 I was able to make all as 3. Now we got to know, in that we got to know greedy as in choosing a maximum frequency element and then trying to make all the elements equal to that maximum frequency element would not work, because here also I choose a maximum frequency element, let's say 2, but maximum frequency element was also a 3. So I need to make sure I am trying to choose all the elements, and then from all the elements I'm just trying to bring the answer whatsoever is possible. So for sure, greedy as in choosing a maximum frequency element blindly and then making all the elements equal to that element would not work. What we have to do is we have, and for sure we know that, okay, how it would not, how it would not work. Now what we have to do is we have to go and try for every number to make all of them equal to that number, which means if I know I have a 3 as one such number, I know greedy would not work. So what I will do is I will try to build and try to say make all the number as equal to 3. Now if I have to make all the number equal to 3, what is the maximum time it would need? Simply as simple as that. Like when we have to say, see, now we broke the problem to smaller problem. That firstly we saw, okay, our greedy choosing the maximum frequency element would not work. So what now? We have to try for every element, which means we have to try making my array, which means the entire array, equal to every element. So again, what we could have done is, okay, we could have chosen to make all the elements equal to, let's say 2 or 3. Let's say I choose all the elements equal to 2. Or let's say I choose all the elements to make equal to 3. Now, when I say all the elements equal to 3, what I mean is, I mean something with the constraints. I cannot go on to every element and will try to build the entire array again. That I cannot know. That I could not do, because I can with this constraints that just says me very sharp and clear that, okay, please land onto every index exactly once. Or if you are even doing, you can simply do some sorting and stuff, but for sure I cannot do sorting and stuff because I want my order to be intact, because I'm concerned about the order itself. So for sure I need to go on to every element exactly once, which means if I am saying I want to make every element equal to 3, now I should be knowing what is the time required if I want to make all elements equal to 3. Now for this, simply we will simply break down to other problem. Okay, now my task is, if I have some elements with me, now I also know I have some 3s with me. I also know I have some 3s with me. Now bring me the time it requires to make all the element equal to 3. With this fact, I am also saying I will go on to every element exactly once, because by constraints I was saying I could only go to every element exactly once. I cannot go to every element again and again. So with this 3 as a location, I know one thing for sure, that I can go to every element exactly once, and I'm also doing the same stuff. I'm only going on to all the 3s. Now you know why I'm going to only 3s. It is the reason because I know I want to make all the elements equal to 3s. Now when we say that what is the time required, what is the maximum time required to make all the elements equal to 3s, as simple as that. See how we say, if it is a 3, it is a 3. You want to make all the elements equal to 3. So in time 1 it will become a 3, right? In time 2 it will become a 3. So for sure, both are going from both the sides. Both will try to build the answer from both the sides, right? So what I can say is, if the index is I, if the index is j, so for sure I will be able to actually build. If it is a 5, it is a 1. So I am saying 5 minus 1 by 2, because for sure if it is a 4 by 2, it is actually a 2. Saying 2 is the maximum time it would need to actually build my answer. Let's see, if I have this 8 minus 5, it is actually a 3 by 2. Again, it will actually give me a 1.5, right? Again saying, in 1 second, ultimately I just want to have a 3 by 2. In 1 second, I will be able to make all of the middle ones equal to 3. Cool. The middle ones are sorted. But yeah, please make sure you want in what is the time required to make all the elements equal to 3. So I am choosing these elements, the blue elements. I know the indexes of these blue elements. For sure, I know the indexes also. Now, with these indexes, I am calculating the time it would be needing to actually make all the middle elements equal to that element. And with that, I just know, okay, the index is j, the index is I. So for sure, you will be able to make all the elements between them equal to this element 3 by just saying the time required will be j minus I by 2. So now, you know, the time required here will be 2 seconds. The time required here will be 1 second. So for sure, just imagine that you have nothing in this side and nothing in this side. Just imagine that part for now. So if I would have asked you, what is the time required to make all the elements in this equal to 3? What would you have said? Is it just 1 second or it is 2 seconds? You'll always say a 2 seconds because it is the maximum time required. I will not count 1 because 1, okay, for sure, here it is. But meanwhile, when I say 1 second, in 1 second, it will become a 3. In what will happen in 1 second? It will become a 3, it will become a 3. In 2th second, it will also become a 3. So for sure, if I want to make one element equal to that maximum frequency element, if I want to make one element equal to this element, let's say 3, so I have to go and count for, okay, what is the maximum time between this element 3, which means, for sure, here the time required is 2, it's required is 1. So for sure, the maximum time here in between them is actually a 2. So to make all the elements equal to 3, the time required will be actually a 2. Cool. Now you have this time required with you. Okay, now you have this time required with you, which is actually to make equal to 2. But you will say, Aryan, are you mad? You did not counted all these elements which are on the side. Will they not be equal to? Will you not make them equal? Yeah, I can make them equal. But how to know how to make them equal? Because in one step, it can go as 3. Let's say if I had another element, let's say I have another place, let's say this 11. So, in one step, it can go back 3. In one step, you can go back 3. Okay, cool. In other step, it can go here 3. But where it will go? It will go back this 3. It will go back this 3, right? So you need to make sure, okay, you are counting this stuff properly. How you can do it? By simply placing the same stuff again. Same stuff, as I showed you, simply placing the same stuff again saying, okay, it is an index 12, it is an index 13, index 14, index 15, index 16. By simply saying, okay, the element at index 1, it will actually be lying at the index 13. Simply saying, because I know I have 12 elements. I have 12 elements with me. If I am doing a cycle, this element which was at the index 1, it will actually be at the index 13. So either what I can do is, I know, okay, I am actually maintaining the indexes of every element, which means every number 3. Okay, I know that it's at index 1, it's at index 5, it's at index 8. So basically I'm comparing, okay, 5 with 1, index 1, 8 with index 5. With this 8, I also know, okay, I have some remaining elements left which I need to make sure. But I also know, okay, the 3 elements are after this 3 and 1 element was before this first 3. Okay, it is also 1 element before this first 3. And first 3 I actually can imagine at index 13. Index 13 is actually here, index 1, plus 12 is actually an index 13. So either build this entire array again, or you can actually imagine the first occurrence of this particular element 3 will actually be at the first occurrence index plus 12 will actually be the again the occurrence. So now what I will do is I will just subtract 13 with 8 to get the distance between the last and the first element, because for sure you can also combine last and the first element. And that's how for this number 3 you're gonna try what is the maximum time it will take. What is maximum time 3 will take to actually build the entire array as 3. But Aryan, you wanted the minimum time, right? Now why are you thinking of maximum time? Why are you saying of maximum time? I said it's the maximum time for 3 to build the entire array, but I will try for every number. Here I tried for only 3. Next time I will try for other number, let's say 2. Next time I'll try for other number, let's say 1. With that other number, which means here I tried for a number 3. I will get the maximum time for this 3 is, let's say, maximum time for this 3 is actually a 1. Maximum time for 2 is actually a 2. Maximum time for 1 is actually a 3. So I know maximum time for every element, and for sure, you know, to know the maximum time of every element, you just need to go the indexes of that element. And when I say indexes, I actually mean the array like this and the repeated array like this. It will actually mean saying going on to every index at max twice, no more than that. Although you will not go twice, you will just go index plus 1 times, because you know you are only going at the first index again for the last one, right? So now you know, okay, I will get the maximum time for every element. That okay, for this element 3, what is the maximum time? What is the element 1? What? And see, it's not the actual time, but yeah, I'm just showing you. So it's okay, let's say, okay, for this 3 the maximum time is 1, for this 9 the maximum time is 3, for this 2 the maximum time is 2, right? So I know one thing for sure, I will just get the maximum time of every element. And why? Because I know one thing for sure, I need to go on to every element. I got the maximum time of every element to make that entire array equal to that element itself. I got the maximum time. Now out of those all maximum times, I need the minimum time, because I want the minimum number of seconds. So what I will do is I will go and track the indexes of every element, and also make sure to have that cycle effect. Please also add on the index I plus number to get that last index also, because for sure you are comparing index I with index I. Basically you are just let's say if you track the position, which means what I will do is I will make another array of indexes for every element. For this 3 I will make another array of indexes. The 3 array of indexes will say, okay, the indexes for 3 are actually 1, 5 and 8. Now I have got the indexes of 3, which is 1, 5 and 8. Now I need to build this distance, which means saying for the 2 consecutive distances 5 and 1, the gap is actually a 5 minus 1 by 2. Saying okay, the gap, the effect or the time it would need to fill this gap is actually a 2 seconds. Okay, to fill this gap the time needed is 1 second. Again, you know, for the first and last element you also have a gap which is from here to here, but you don't have to draw the cycle and stuff. So what you will do is you will add another index in the last, will actually be a 1 plus the size of this array, which is actually a 12. So 1 plus 12 is actually a 13. So now you will compare, okay, 13 minus 8 by 2, it will actually be a gap distance time which actually be needed to fulfill this. So with this you will take whatsoever is the maximum time it will need it to fill the gap, which means to fill this entire array with this number 3, and this stuff you will go on and repeat on every element. So now you know, for the number 3 you went on to all the indexes of that number 3, and when I say all the indexes, it actually means you are going on to every number exactly once. And same you will have it for 2. Let's say that number 2 is here and let's say here. So again you will go on to 2 exactly once, because you are going on the indexes and seeing the gap between them, and that gap will define how much will be the time needed for that particular operation to actually fill in that gap between these two numbers. And to modify and to actually have an effect of the gaps in the end, you actually bring in this number again by saying the index of the first number plus that the whole size of the array. You'll just have added and bring it to the end to actually bring that number to the end to have that gap effect of the first and the last number. Cool. That's itself what I have to do for this entire problem. I hope that you guys got it. Let's quickly jump onto the code. It's very simple. First, as you know, you have to keep track for every number n what is the position like. So for this number n, for the number n of this entire array, I know, okay, what are all the indexes at which it is placed. So for this number, I am just tracking all the indexes which this number is placed at. Now I will have my result as int max, because I know my answer will actually be a int minimum. No, now I will just go on to the map. For that map, I just grab that element and the entire indexes, which means the entire position vector which I have. Okay, for this position vector, it is actually grabbing all the indexes it needs. It is grabbing all the indexes, which is 1, 5 and 8. But I also know I need to add other index, which is actually a 13, which will be a out of bound of this entire array, because you know, to have the gap between the first and the last one, you need to have other index, which is actually a 13, to actually simulate that rounding effect. So I simply added the first index is actually a 1. It's actually a 1 added with the size of this entire array to actually get this number 13 added at that index positions. So now I have got all the positions. Now you will simply do one thing, simply compare this number I with the previous number, which is I minus 1. So what I did is simply getting the maximum of that number by simply saying position minus position of I minus position of I minus 1 by 2, simply giving me the gap timing, the time to fill this entire gap. It is this time, and I am taking the maximum time for this number, for this element, right? Because for sure for this element, it is the maximum time it have, which means in this time as seconds, it will actually fill in this entire array nums with this time t. So I have got this time seconds for this element, and for sure I will try and for every element and take the minimum time possible. So with this result, I am maintaining the minimum time I will get in for every element. So I'm just grabbing the minimum time whatsoever I could have found and ultimately giving that as answer. Cool. I hope that you guys got it. We'll simply quickly jump on to question number 4. It was a very hard question, but we'll actually go on and see it pretty easily. Cool. Let's quickly jump on to the comments, but yeah, meanwhile, can we please smash that like maybe to 8 likes? We have that ritual going on, but as we know, okay, we are a bit late in today's video, so we'll actually keep it short and concise and not go on to that like part a bit. But yeah, please make sure that you like it and do the ritual correctly. Let's quickly read the comments. I took 1 plus R, 4 done, 4 myself. Boy, I was waiting for your live. Iknath, no, thank you so much. Last 2 can't solve, trying for the past 3 months. No worries. Already liked, have contest, miss all 3 after months. Haha, boy, I was waiting for the live. Go to sleep, buddy. I did in place. Simple travel. Yeah, I only did nodeless whether to pointers to pointers. Let's see who ran the best. I'm having OA questions of Google's cool that will be added. I took 1 plus hours. I solved the first 3 within 40 minutes. No worries. Thank you so much. बस 3/4 नहीं होता. Okay. 1 and 2 होता है. Cool. No worries. I tried BFS with source और maximum frequency. मीडियो BFS लग गया था 3rd में. BFS 3rd में. BFS 3rd में. That's ये बाइनरी सर्च मैंने भी सोचा था, उसके बाद कैसे सोचा. कूल. 3rd हैप्पी फ्रेंडशिप डे. ओ आर्यन भाई 4th क्वेश्चन को बाइनरी सर्च का इंट्यूशन आ गया था पर इंप्लीमेंट नहीं कर पाया. 4th on binary search, that's actually very tricky. Like many things you can try on 4th. It's actually very tricky. Take the element which has the least distance and the element Niti Aryan, how to prepare for OA. Today I solved 2 by 4th in ID5 company OA. One question was hard SQL questions, out of these which I am unable to solve. Those who use ChatGPT, they got advantage. Yep, that is true for something, but yeah, if it is not programming based, we can actually see it and get it done by some things. But for programming, I will not suggest. But yeah, for SQL questions, it's just maybe we can just have some Leetcode seen or done. Yeah, that is true. Yash Bankar, वो थोड़ा होता है. But yeah, मतलब if it is not monitored, we can also do it. I'm not saying, but yeah, if it is monitored, then I will not recommend. But yeah, SQL and stuff, hard stuff, then that's a tricky one. It will not work because choose help other. Cool. Let's quickly jump on to question number 4. That we have less time. Cool. Minimum time to make array sum at most x. Now the problem says that okay, we are having a nums1 and we are having a nums2. Now what we have to do is I am having two index array nums1 and nums2, and every second for all the indexes the value of nums1 is incremented by nums2, which means at a second I will add this nums2 to nums1, which means I will add a 1 to this 1, 2 to this 2, 3 to this 3. Now what I am also said is you can do the following operation: choose any index and make that index equal to 0. So before applying this add operation, you can choose one index and make them equal to, and make that index equal to the index 0. Cool. Now what if you do that and make that index equal to 0? Ultimately, it will just help you to reduce that sum, which means let's say I make this index equal to 0. So rather than, you will see that okay, it was added to a 6. 3 plus 3, it became a 6. So what I could have done is I could have simply made this a 0. Then with this making a 0, if it would have been added, it would have at max become a 3. So just it is one such operation, which means it can just, you can just reduce any number equal to a 0. Now cool, that you have done. Other thing is you are also having an integer x. Now what is integer x actually is helping us with is we have to return the minimum time, because you know what, every second I am just making one number 0, and also I am just adding this whole stuff down here. Now what is the minimum time in which you can make the sum of all the elements of nums1 to be less than, which means ultimately, you know, in nums1 this is added. So ultimately I am concerned about the sum of nums1, and at what time it is the case that the sum of this nums1, which means that the sum it's actually less than or equal to this number x. Or basically saying -1 if it is not even possible to make my nums1 as sum as 0. So we look at the example. From the example itself, we actually try to build on the answer. Now first thing is, what is the minimum time? So first thing can come for sure is I will try to do a binary search on my time, which means what I can do is okay, I'll just choose minimum time as 0, because for sure it can be possible that my sum of nums1 is already less than 0, which means less than my x. Okay, so minimum time required will actually be a 0. I know, okay, my minimum time, it can be actually a 0 required time. But what can be the maximum time? Shall I go on and try for some big number, or what? What can be the maximum time? It's simply, see, now we have not gone on to okay, if we use a binary search, then how will actually verify that with this time it's actually possible or not? That's one such case. But even if of thinking of binary search, we thought of just one thing: what is the maximum time which actually can be possible? For that, we'll simply look on the example itself. Here itself, we just choose this first number and just make that as 0. Cool. And then we simply added my 2 here, simply added my 3 here. Okay, it just became like this. Now In the next step, I simply choose this next number and made them as 0. Okay, earlier I made this as 0, now I made this as 0. Cool. Now in the next step, you saw I made this 3 as 0, which means whatsoever I had here as sum, I made this as a 0. Now I am saying, once you made this as 0, once you made this as 0, once you made this as 0, let's imagine that still you tried your level best to make everyone in order. Let's say you tried your level best and tried to make everyone, because everyone in order, you tried to make everyone as 0. Still, would you like to try on some other number again? Which means, at every position, one thing at every position, because see, right now I'm just trying to find out what is the maximum time required. Okay, the time is 1, the time is 2, the time is 3. Now again, I am trying for time equal to 4. Let's imagining right now the sum obtained, it is not less than equal to my x. Let's imagine that for now, which means I will try for the next time. Now I am saying, for next time, what is the next number would you like to make the sum as equal to 0? So one thing is for sure. Now, one thing is for sure. Would you actually be wanting to make any other number equal to 0 back again? Yes or no is a question. Because if yes, then it will just keep on going again. If no, then you would know, okay, your maximum time required will actually be a n. Now, that is one point for us to know, okay, what will be the maximum time required. Now, if it is the case that, okay, it is a maximum time, now we have to judge, is it actually okay to go on and actually make the existing number which we have already made as 0, shall we go on and make that number from nums1 again as 0 or not? Shall we do that or not? But yeah, before that, if you guys are watching, can you please smash the like button and reach to 80 likes? That would be super great. But yeah, quickly jumping on to the question back again. Now, the question was, at time 4, shall we go on and make other number again as 0? Now, which means that what we will do is we will simply make this number as 0. But again, something will be added in the second number and something will be added in the third number. Now, keeping everything as minimum as possible, let's imagine that we have all the numbers as 1, 1 and 1. Now Aryan, if you want to keep everything as minimum as possible, then why you did not take everything as 0, 0, 0? Because if everything has 0, 0, 0, then adding would have no effect at all. So I would have never added, which means I would have never gone on to any time and I would have made every number as 0. So by just saying, okay, adding has some effect, so I took the minimum number possible. Now, if I'm taking the minimum number possible, I know one thing for sure, that here it would have been a 1 rather than a 2 at this stage of time. Now, if I have a 1 here, and if let's say in the next step you are adding something, and for sure you made a 0, but still you have to add this nums2 back in your number, so you will simply add a 1 here and you will simply add a 1 here. So what you did was you erased a 2, but also you added a 2. So it is one such example to actually represent, okay, adding or basically erasing a number back to 0 from nums1 will actually not help us. So one thing what we got to know, and see, that is one such example. You can actually build many examples to reach to a point that at max n chances will be given, so that, okay, you try to make every number to 0. Now some of you will try to build an example such that n plus 1 chances are required to make that equal to 0. But what I will say is that simply saying that when I say I erased an element and make that equal to 0, I am following an order of being erased that element. You saw that order of what I followed or what this question followed. If he wanted to erase an element, he erased the smallest element first. The smallest element first, which means he erased a 0, then he erased a 2, then he erased a 3. What if I would have erased a 3 first? Okay, I would have erased a 3 first. Then what would have happened is, okay, 3 is erased and other stuff is simply added. Now, simply this number 3 will add back to a 0. Simply number 3 add back to a 0. So rather than building a 2, because here I erase this number first. So this number 1 added back, the number 1 added back. So it became a 2. 1 plus 1. 1 plus 1 will become a 2. What if I would have erased my number 3 at the beginning? So this number 3 and 3 will add back for the second and third chance. If it would have added, you would have simply got a 6 here rather than a 0. So that is one such observation we got. Okay. Firstly, we saw what could have happened. It is one such option. What could have happened is maximum number of times I would like to try and erase and nums1, it will actually be just one time, which means one position I will try to erase only once. So maximum number of time I could have actually erased some position will actually be a n. So for sure in n seconds I should be able to bring nums of 1 whole sum less than x, which means if I am not able to bring the sum less than equal to x, for sure I need to say my answer is -1, because it's never possible in that case. Now, so we are actually saying that in just n seconds, when I say n, I actually mean the size of the entire array. In n seconds, it's actually possible. So again, when we say it is possible, we need to say for the optimal possibility. Now, we saw the optimal possibility is always the case then when we will actually erase the element which has the smaller nums first and the larger nums in the last. And why is that the case? Because ultimately in my mind, let's imagine that I know the maximum time it will take is 3 seconds, which means the entire process will go on for 3 seconds. So if ultimately I know if I would have erased this in the very beginning, so this 3 will keep on adding in the second and the third second. This 3 will keep on adding. Right, so if I would have erased this in the very beginning, my 3 will add in the first, in the second and the third second. So this nums of 1 will have its impact with this sum as well, which is 3 plus 3. But if I would have erased this in the end, which means it will simply become a 3, existing 3, it will simply become a plus 3 in the first second, become a plus 3 in the second, but in the third I will erase this entire stuff. So you know, earlier if I would have erased this initially, so it would have given me an impact of 6. But I erased this in the end, so this impact of 6 is actually reduced to a 0. But I will have the same stuff for this one. I know I will simply could have added a 1. So if I erase this in the beginning, I would have simply got in the end as 2. For the second 1 added, and for the third second again a 1 added. So I will simply get a 2. But if I would have erased this in the end, so I would have simply got the effect as, okay, simply add a 1 and add a 1. So simply it would be a 3 ultimately, which I would have erased. So you know, ultimately, is the impact of 2 good for you, or is the impact of 6 good for you? Which means I would have said, okay, I am simply adding a 2 and a 0, or I would have said, okay, I will add a 9 and something less, which means a 0. So you know one thing, you got to know one thing for sure. It is always beneficial if I know, okay, the maximum time needed is actually a 3 second. I know one thing, I assumed I know. It is maximum time is actually a 3 second. So for sure, I will try to erase an element which is having the maximum nums of 2 in the very end. And whatsoever is actually having the lesser nums of 2, I will erase that in the beginning itself. And that with the example itself, we can easily see. And with that, we can actually know, okay, it will be the most optimal erasing strategy for us in nums of 1. So now, up till so far, we have got to know 2 points. That maximum time I could have taken is just n seconds, which is actually equal to the size of my nums of 1. And other point is that it is always optimal to actually erase the number which is having higher nums of 2 in the end and smaller nums of 2 in the very beginning. Why? Because if it is having a higher nums of 2, it will simply in the start, it will simply keep on accumulating and it will become very big because it's having higher nums of 2. If I will erase that in the end, that higher impact will actually be very more, which means this 9 it actually reduced to a 0. While for the smaller number, which is 1, its impact will be just a 1. So its impact will be very small. So even if it keeps on adding, it will not affect me at all. So one thing for sure, I will try to erase the number in the order that, okay, as the time elapses, I will try to erase the number having the higher nums of 2. So now we have got 2 points. Firstly, maximum is the time required is n, and always erase the smaller nums of 2 first. And ultimately it also means that we erase higher nums 2 in end. And when I say end, I actually mean for the time. Let's say if I have the time as 3 seconds, so ultimately in the 3 I will erase for the higher number, and for the small number I'll erase at the very beginning. Right? That is what we have seen so far. Now coming back to what is the minimum time required. So again, I just know one thing for sure. I need to get the minimum time required. So what I could know, okay, minimum time required. So I will try for 1 second. I will try for 2 seconds, I will try for 3 seconds, and so on and so forth. I will try for every second. Now, can I try for all the seconds? Let's see. My nums, when I say seconds, I know I can go from 0 to n. Cool. Let's see. Yeah, my time is actually B1E3, which means I can try from 0 to 1E3 seconds, which means I will try, okay, can I make my nums of 1, and how? And I know for sure when I need to make my nums of 1 less than it's some less than equal to 4, and I know, okay, I will try on for every second because I know I will go on from the minimum time. Now in this you can also apply the binary search. How? We will see, because ultimately, see, when we think of applying a binary search, we think of applying binary search when we know, okay, we have these numbers from 0 to n, and I just have to go from 0, then 1, then 2, then 3, and then so on and so forth. So at any point of time, let's say at t time, if I got, okay, my nums of 1 whole sum, it can actually become less than my number x. For sure, this time is the minimum time which is required. So one thing, I can simply go on from 0 to n, and I can simply say on, okay, it is the minimum time which is required. Now comes the tricky part. You are saying you will go on for every time. In this you can apply binary search for sure. You are thinking you can apply for sure, but whenever I say I can do that stuff in t time, how will you actually verify that that stuff can be done in t time or not? That is a big task, which means I know, okay, I will go on to every second, and let's say for in mid second, which means I'm going in order, which means I'm going on from minimum time to maximum time. I know for some t seconds, is it possible that my nums1 sum, and when I say nums1 sum, I actually mean, okay, I can remove an element, I can add it, and so on and so forth. So okay, and when I say I can remove it, I can only remove that element t times. So that is also one condition. Please make sure in mind. Now at this t time, how will you make sure that after doing the steps, which means after doing the steps for t seconds, or after doing the step on t indexes, your sum is less than equal to the number x? How will you verify that? How will you make sure that, okay, that is happening? Again, for that part, now leaving the binary search part, now my main task is actually to focus on that for some t time. How will I make sure that the sum is less than equal to this x? Simple. Let's say if I just say you the time is 1, which means you can only replace just one element. This means you can only make my one element equal to 0. So what you could have done is, okay, your sum is actually equal to this 1 plus 2 plus 3. Right now, when I ask you, you can make one element equal to 0, right? And you can simply add the other element again, which means you can at t equal to 1. Ultimately, what could have happened if everything goes well? What could have happened is ultimately nothing. Let's say nothing. You have made 0. Nothing. You have made 0. You would have simply got this number nums of 1. You would have simply added this in this entire stuff. At t equal to, what could have happened is, okay, you have this entire stuff. You would have added this nums of 2 again. So basically, when I say that nothing is being removed, nothing, because ultimately, see, what I'm confused is what number I should remove. That I'm confused, right? So if I am imagining I'm removing nothing at all. So what happening is, in nums of 1 at t equal to 1, nums of 2 is added once. At t equal to 2, nums of 2 is added twice. It's happening, right? It's added twice. It's added, see, in this, it's added once. It's added twice, right? It's added once, it's added twice. That's happening. So what I could have done is, if I'm not removing anything, ultimately, in this nums of 1, so basically at some time t, let's say 2 seconds, my total sum, if I'm not removing anything at all, my total sum will actually be a nums of 1 plus 2 into nums of 2. And when I say nums of 2, I actually mean the sum of nums of 2. So that will be a sum, entire sum, where I'm not removing anything at all. But I know that I can remove something. So at t equal to 1, I can remove something, right? I can remove something. Now, when I can remove something, what actually I mean is, I could have removed this, or I could have removed this. I could have removed this. Anyway, anything I could have removed. So again, for t equal to 1, I have how many options? I have n options. Again. So that I show. For t equal to 1, I have these n options. Whichever I can remove, I can remove. So if I remove something, what will be the impact it would have given me in my total sum? Because my total sum, my t sum is actually it's actually a nums 1 plus 2 into, t into nums 2. That's my sum. Now, if I'm removing something, let's say I remove this, or let's say I remove this. So basically, I'm just removing the impact what it could have given me in my this sum. What this impact could have given me, it would have given me 1, which is actually this number itself, which is the nums of, let's say, I, plus my time, 1 time, right? And let's say the number 2, which is the nums of 2, nums 2 of I. It is nums 1 of I. It is the impact which I would have reduced from this if I would have removed that in the 1 second at t equal to 1. And that I can repeat the same process for every number. I can remove this, I can remove this, or I can remove this. So now one thing, that you want this entire stuff to be as minimum as possible. And that you will be subtracting this stuff, this above stuff, from this below stuff. Ultimately, you want this below stuff, which is the total sum. You want this as minimum as possible. So you would be wanting this above stuff to be as maximum as possible. So again, coming back, we know we have broken down the problem to, ultimately we were actually thinking of the minimum what we could have got, this minimum sum. Now broken this minimum sum to actually the total sum minus the actual impact at any time. Let's say at any time t, I could have impact of one element, right? So one element, it can be either first, second or third. So I could have said, okay, I will try to grab the maximum impact of at some time. And why maximum? Because I know ultimately I'm concerned about getting this minimum, because I'm concerned about getting the minimum, because for sure the minimum one can only be less than equal to my number x. Now please make sure that this question is hard. Only 64 people are able to solve it, if I'm not wrong. So please make sure, okay, 41. Oh, it's actually 41. So out of the entire contest is over. Still the number of submissions are 41. So please make sure that it's a hard question, so you are grabbing every point whatsoever is being spoken at every point of time. So that's the reason it's actually a hard one. So if it's not very intuitional at the first point, please watch this video again, you will actually get it. Now coming back to what we wanted ultimately is, we want this as the maximum sum. But one thing is for sure, I will be trying for every t. Why for every t? Because for sure, you know, at time t equal to 1, I could have chosen any number. It could have been a first number or a second number or a third number. And when I say a third number, I just want what is the maximum impact this third number can give me. When I say a third number, I actually mean only that number itself, because it is t equal to 1. At t equal to 1, I'm only concerned about that number, because for sure I know in time 1, I can only make 0 one element. So if I can make 0 only one element, I can make the first one 0, the second one 0, the third one 0. I can make any one of them as 0. So again, for this time, I have I options. Again, for the next time, what could have happened is, for time t equal to 2, what could have happened is, okay, I can choose this element with the any of this element. So basically I just need to choose two elements to make them 0, and I know the order to make them 0. I will always make the smaller element. When I say smaller, I actually mean by nums 2. Now what I mean is, if I am at time t equal to 2, I know I can make two elements equal to 0, and I also know the order of these two elements, how to make them equal to 0. I will make the element equal to 0, first one which has the smaller nums of I, and then the one which is having the higher nums of I. But for that element t equal to 2, it could have multiple options, which means I could have taken this and then this. I could have taken this and then this. It could have been anything. Which means once I took these two. Now whenever I say I took these two, I am maintaining the order that, okay, I will always take the first one first and then the next one next, right? I don't know, always next. Other options I can take these two. Other options I can take these two. Oh, for time t equal to 2, I could have got all these options. So is there any way I could have got, okay, because ultimately you know what's happening here is, at time t equal to 2, you are saying I can choose, let's say, these two numbers, because for sure I know that at time t equal to 2 you can choose two numbers. Now if you can choose two numbers, what actually you are saying is that at time t equal to 1 you will use this one, at time t equal to 2 you will use this two, because ultimately at time t equal to 2, which means you have time as 2 seconds, which means you can make two elements as 0, which means you can have the impact of two elements. So for sure, you could have gone for this 2, you could have gone O of n square to make all the pairs out. But I am saying, hold on, you just went on to, at time t equal to 1, you just went on for all the individual pairs, right? So if I am saying that for at time t equal to 2, if you want to find the impact of the 1 and 3, and you also know the 1 will be taken first because it has smaller nums of 2i, and the 3 will be taken next because it has the higher nums of 2i. So for time t equal to 2 seconds, if 1 and 3 are taken, 1 will be taken at time t equal to 1 and 3 will be actually taken at time t equal to 2. So this time t equal to 1 you already computed previously when you were actually finding in for time t equal to 1, and that's how I know, I could have used a DP kind of stuff, because I know else I will be going on for every time I will go on and do a n square. But I know one thing for sure, I cannot do a n square, because I'm not saying n square. Let's say I'm just saying, okay, for time t equal to 3, you will go on and do a n cube stuff then, right? But you don't want that stuff to happen, right? At time t equal to 4, you will be doing a n raised power 4. So that you don't want. And how you don't want this? Because you know, for time t equal to 2 seconds, if you choose any pair, let's say if you choose a 3, let's say if you choose a 1 3 as a pair, now you know one thing, the 3 will be actually operated at time equal to 2, and the 1 will actually operated at time t equal to 1, and time t equal to 1, only one you had already computed before, because you know you are actually going on from smaller time and seeing, okay, for time t equal to 1. And why we are actually going on for small time? Because we know for time smaller, at t equal to 1, I can only remove one element. At t equal to 2, I can remove two elements. Any two elements I can remove. So I know one thing. I got to know one thing. And see, up till so far we have got to know many things. Now here I got to know one thing. To build my answer, I'll go on my every time, which means time t equal to 1, time t is less than n, less than equal to n, and time t plus plus. Cool. As I go on to every time, I also know one thing. I have, because you remember at time t equal to 1, you were trying on for every element, right? So I also know one thing, okay, for every time I have to go on to every index. When I say every index, I actually will go on to every index, which means from I equal to 0, I is less than n, I plus plus. I am going on to every index now. Now, for every index, what I need to find is, okay, for every index, I need to make sure, okay, I know I have to use a DP, which means I have to do a memoization, okay, or I have to basically make something as a DP state. Now my DP state, for sure, if I'm using two variables, which is I and time, so I can simply say my DP state is I comma t. Now great, my DP state is I comma t. Right now, what I'm concerned about is this maximum thing, because I want I'm concerned about this thing, and I want this to be maximum, because I'm subtracting this stuff from my total, and I want this total to be minimum. So I want this to be maximum. Okay, for sure, I will be taking this as maximum. Now, when we're taking maximum, we'll take maximum of what? Two stuffs. For sure, one thing we saw, okay, what if I take this element? Cool. If I take this element, I will simply add the impact of nums1 of I, which means if I am at the index I, so I will have this index I plus the time which I have taken plus nums2 of I, which will be the impact if it would have been taken for this t seconds time. So if that number was taken, if this ith number was taken, so it will have an impact of nums1 of I, now plus t into nums2 of I, that will be the impact of this one at t seconds. But what if I don't take this one? Okay, I just skip this one and I went on to other one, right? So you were keeping track of what you took and what you did not. So if, let's say, I am saying I did not choose this one, so whatsoever I have got so far from the previous one at this time, please give me that. Which means right now I am choosing my particular number, but what if I don't choose this number? So if I don't choose it, simply saying whatsoever I have got so far from the previous number, just give me. And how it is helpful, it will simply keep this, okay, whatsoever maximum you have, you will simply get that maximum in this I. Now you know you are going in from this I order, and please make sure you know you are going in this order. You can only go in this order only when you have your sorted nums of I, which means this thing, it should be sorted on the basis of my nums of 2 of I. So what you will do is you will simply sort my nums2 of I, or you can simply take a vector which will actually be having vector, will actually be having a nums2 of I and nums1 of I, and you will simply nums1 of I, and you can simply sort this vector on the basis of nums2 of I, right? Simply sort down so that nums2 of I smaller is actually in the beginning and nums2 of I larger is actually in the end. Why it is important? Because for time t equal to, let's say, 2 seconds, I will actually operate on the smaller nums of I before and larger nums of I later. So that's the reason it's actually important. So simply have a vector v and simply sort that vector down on the basis of what? On the basis of this nums of 2 of I. Now coming back, have you closed the window? Nope. I guess I don't have got a WhatsApp message from them. I need to. Thank you for reminding. Yep, that's good now. Now coming back to thank you so much for reminding. But yeah, can we please smash that like baby to 8 likes? That would be super great. But yeah, let's quickly jump onto it back. Now, you know one thing, I know one thing. We are trying to simply build the example that, okay, if the number is actually added, it will actually be added. But if it is, let's say, not added, or basically for the next step, let's say this one was added for the time t equal to 1, let's say it was good to add it, but still I am trying on for every possibility. So I am trying on, let's say I would have added it, but if I would have not added it, then I would have simply said, simply take whatsoever you have gotten from the previous result. Previous is simply saying whatsoever you are having in I-1, because you know one thing, if it will actually contain this result here. Now, what is the next time? Let's say for this I, let's say I was actually a 2. So here the I will actually be a 1. For next time when I will actually be a 3, here it will actually be a 2. So basically you are just taking the maximum out of every stuff which you are building right now. So it will actually becoming maximum. So basically what it actually means is your dp of n-1 comma t will actually be the maximum. Now for sure, you know, I know that I equal to 0, I-1, it can actually give the runtime error. So what I can do is I can start from I equal to 1 and I can go from I is less than equal to n. So if I just start from I equal to 1, so I need to make sure, okay, my indexing is I-1 and nums of -1, right? That's a basic thing of DP which we need to make sure. Now coming back to what we did so far is that, okay, I have got, okay, if I choose this number, so for sure, and see that I'm explaining with time t equal to 1 seconds. If I choose this number, okay, the impact of this is added here, but ultimately I wanted one thing, that I should be getting the maximum, because ultimately I can also choose the next number. I can choose the next number. If I'm choosing the next number, then what could have happened is I could have chosen the maximum, because ultimately I'm concerned about the maximum I could have chosen. So I'll just get the maximum out of whatsoever I can choose. So maybe, okay, if I choose this ith number, it will have this impact. What if I do not choose this? Okay, just get whatsoever you have it. So whatsoever you have it is nothing but dp of I-1, which means if you have not chosen the ith number so far. Now cool, that is, we have made a recursive kind of a dp kind of stuff so far, but maybe it's wrong, maybe it's not right. Cool, let's look at it at t equal to 2. Now at t equal to 2, how our dp will help us? Now we know at t equal to 2, okay, t equal to 2, I am only concerned about t equal to 2, which means my t equal to 1 answer should already have been computed, because ultimately right now I am finding answer for t equal to question mark comma 2. Right now, so as to not go to every of the combination, which means so as to not go to n square stuff, what we did was we use a dp. Now what I actually mean is, when we are actually finding the answer for t equal to 2, we already know the answer for t equal to 1. Right now, what we know for t equal to 1 is the maximum answer possible, right stuff. And for sure, we also know that my dp of I is accumulating the answer for that time t up till the ith time, which means as I am building the answer from I equal to 0 to I equal to n minus 1. So at dp of I comma t, I actually mean at this time t, and when I say t, let's imagine this as 1 second for now. Okay, so I'm just saying up till this point, if I just take this I elements, starting I elements for this time t, what is the maximum sum I can give for this time t, which means for this t operation. When I say time t, I actually mean removing t stuff, which means removing t indexes and making them to 0. I actually mean removing t indexes and making them to 0 out of these I1s. So basically I'm just saying, okay, if I just applying operation on the previous I indexes, I am applying operation for t seconds, which means I am making my t as 0. So what is the maximum sum I can get that I am containing in my dp of I comma t. Now I know one thing for sure. I was about to find the answer for dp of question mark. Question mark means I on and for 2 seconds. Ultimately also know for 2 seconds you are trying to make a pair. Now to make a pair, you actually would be seeing for what? If you are choosing some ith value, which means if I had example of 1, 2 and 3 back, and when I say 1, 2 and 3, I'm only concerned about terms of 2 right now. So if let's say I make the pair as these two. Now for time t equal to 2 seconds, I let's say have, and I know one thing for sure, I'm only going on the indexes everyone's for every time t. So if it is the time t for my I know one thing, if it is I could have chosen any of the previous, and I'm referring for time 2 t equal to 2. I could have referred any of the previous for time t equal to 1. So any of the previous. So basically I will just go and ask my dp itself. Okay, I am choosing my ith index for this time t, which means the impact will be this. For this ith index for choosing at time t, the impact will be this, but it is the time t. What about the time t equal to 1? Because for sure you are choosing this at t equal to 2 seconds. So the impact at 2 seconds for this number 3 will be this much. But what about the 1 second? You could have chosen a 1 or a 2, anything. So I will just simply ask my dp, because it is storing stuff. I'll simply go and ask him, hey bro, what is I could have got if I would have chosen anything previous than me, and also the time has also reduced by 1. The time has also reduced by 1. So I'll simply go and ask my dp, okay, right now for t equal to the impact will be this, but please also bring me what could you have got if anything which is previous of me you could have chosen for time t equal to 1 seconds. And that's how we can actually build in our function. So I know ultimately what we have made so far is this particular function of a dp, this. Now many of you would ask me, hey Aryan, why can't we actually think it in a memoized form? Because no, you cannot think. Why? It's actually important to think it in a tabulation form, or basically in a bottom approach. How? It is exactly what I showed you, that every impact, your t needs to come first. For every time I need to compute my I first. If you are simply having a recursive call, which means if you are simply making a memoization function of t and I, it can be computed in any order. But I'm saying for this particular t, my I needs to compute first, and then only I can go on to my next t. Because for my next t, I need to know the answer for my I plus I minus 1 as well. Although you could have written that itself, but thinking that how to get it, because see, ultimately what we could see is, okay, we had a t. Now for that t equal to 2 seconds, we know we could have got all the n square pairs, but we cannot go for all the n square pairs. So what we got to know so far is, okay, we know for the t equal to 1 we had already computed, and we know that, okay, we are computing that in the order, which means I am going in order. I am going in from smaller I to larger I. Larger time, larger time, larger time, which means if I'm doing it for time t, the time t minus 1 or smaller will actually be computed into I minus 1 states and not higher ones, which means higher I, higher index, lesser time is not possible. Higher, less, like more index, lesser, more index. Just saying that, okay, as we have referred earlier also, that higher, if I have 1, 2 and 3 at less time and 1 at more time is not good. So 3 at more time and 1 at less time. That's the reason if I have my I at this location, I need to find the answer for the previous ones at lesser time, which is t minus 1 time. And that's it. We are actually storing this in actually RT, because for sure at the next t, let's say t equal to 2, my answer will actually be bringing in from the smaller, for sure all the i's will actually go on, but here it actually become to t minus 1, because for sure I have used my time, I have used my one time, which is the tth time. The impact will be this, and ultimately I'm concerned about the maximum sum, because you know I want this maximum stuff to subtract it from my total sum. So I'm just concerned about the maximum sum I could have got at any time t. Now for sure for any time t, ultimately to compute what is the maximum sum you could have got is you used ith index. What if I don't choose the ith index? Cool. If you don't choose it, you will simply get the previous state. Previous state is same. Choosing, not choosing ith index, simply got whatsoever you have got maximum from up till the I minus 1th index, and ultimately adding. If you have chosen the ith index, okay, you added the impact of that ith index, and for sure whatsoever you have got up till I minus 1 index with this time t minus 1, that will actually, you will keep on storing this in your answer. Now summing up back, you will simply go on to every time from t equal to t is less than n up till t plus plus. You will go on to every index. Please make sure you have to go on time at first and then index later on. Why? We actually saw that previously as well. We'll go on to indexes. Now indexes from 1, because for sure it is our dp and dp will access minus 1. So we will get to know, okay, dp of I comma t, it actually will be maximum of, why maximum? Because I want the maximum sum, because that will be subtracted from the total sum, and I want this total sum to be minimum. So it will be maximum of dp of I minus 1 comma t, which means I am not choosing my ith index at all, but if I choose the ith index, the impact will be nums of 1 of I plus t times nums of 2 of I, that will be the impact at the t seconds. Up till the t seconds, the impact of the ith index will be this much, but okay, it is up till the t seconds. What about the previous seconds? What have been the impact so far? So it will be actually brought by dp of I minus 1, because for sure for the t minus 1 seconds remaining, I can only access the previous numbers I have made so far, and that will actually give me, okay, if I choose this ith index, I will have this impact. If I don't choose it, I can simply take whatever I have got previously, and that will be actually the state which actually keep on storing, okay, for every time t, what is the maximum you can actually add up. What's the maximum you can actually add up? And it is the stuff which we have made this. Plus, but make sure that you have to subtract it from the total sum to actually get, okay, what is the minimum. What is the minimum sum it actually has? Because for sure I'm concerned about the minimum sum. It needs to be less than equal to x. So what I will do is, okay, I have got my all such. Now for sure, you know one thing, I know one thing, I have to go on at every time from a time t equal to 1, t is less than equal to n, and t plus plus. I'll go on to every time and I'll ask, what is my sum? My sum is my total sum minus whatsoever maximum sum I have got for t equal to 1. Now for t equal to 1, what is the maximum sum? Now it will be bought in my from my DP. What is this thing? We'll see. But this total sum minus, it's a maximum sum, because if we are taking the maximum sum, it should be less than equal to my x. If it is true, I will simply return my time t, because it is the minimum time, because I am going on from smallest time to the maximum time possible. But again, what it should be here, I am saying I need to get for a time t, what is the maximum sum I can get. Now I am not concerned about any indexes, and what I have been storing is dp of I comma t, which means up till this point, up till the ith point, for time t seconds, what is the maximum sum you can get up till ith index. So I want for time t seconds, I have this entire array with me, so I will say for time t seconds, I will go up till index n minus 1, or basically saying, okay, dp of n is saying up till the index n minus 1, because you know I am choosing indexing 1 bytes. So I'm just saying I will just choose dp of n comma t, saying that dp of n comma t will say that, okay, whatsoever I have got up till the last index, whatsoever I've got, maximum sum give me for time t seconds. Because n will just say me, okay, everything up till this point will covered. If it would have been, let's say I, it would have said, okay, everything up till this point is covered. But ultimately I want to cover everything out for this entire array. So I just say, okay, up till n, which means everything up till everything up till the end of the array is covered. So I'll just say, okay, return me for this time, what is the maximum sum you can get, considering you have the entire array with you. You will subtract this from the total sum what you have got so far. If it is less than equal to x, simply return that sum with you. And that's how you can simply solve this. Here itself, you can apply a binary search. Although overall complexity will remain still O of n square, because you are applying a DP here. The binary search part you can apply here. You can apply here a binary search and can actually reduce this to log n. Rather than n, you can actually reduce to log n. But ultimately, it will still remain O of n square plus log n. Although you can reduce this next part, but still, it will still remain a O of n square part. And that's how you can simply get this done. I hope that you guys got the entire intuition from very beginning. Okay, how we know that, firstly, we know that the maximum it can go to n. Then we got to know, okay, the order of nums of 2 is important. That, okay, smaller nums of 2 will actually be used first, higher nums of 2 will actually be used next. Next, we thought and learned that how actually it is required that we will actually find total sum, and then we need to subtract some maximum stuff which we needed, so that to get the final answer, which should be less than equal to x. Now to get that maximum sum, we need to start building in from very start. We started with t equal to 1. Okay, we can choose first number, next number, but for t equal to 2, we were actually choosing in 2 numbers. Now for choosing 2 numbers, it can actually become n square pairs. Oh, that will actually result in a higher complexity. So maybe we can use something we have computed previously. How we can use that? Simply saying, okay, I can simply apply, I have simply found the answer at t equal to 1, and I also know one thing, for t equal to 1, I will have the lesser numbers. So I know one thing, you know one thing, that for t equal to 1, you will only use the lesser numbers. For lesser numbers, you have already computed what's the maximum sum it can give me. So for t equal to 2, you can use this number, but for t equal to 1, you can simply go and ask your DP to give you back, because you have already computed at t equal to 1 when you were choosing only one number up till this index, whatsoever maximum time, whatsoever maximum sum it can give you up till t equal to 1. Up till this index I minus 1, you can ask that from your DP itself. So that from that we actually got to know, okay, we can actually use a DP then we actually thought of using and building my DP state. Now how we build that? We went on and got to know one thing. Okay, I have to start on from time first, because for sure I'm going on at every time, and at every time, because for sure. And how we know every time and then index? Because we know we started with the index 1. With the index 1, I'm going on to every index. Cool. With the index 1, which means, okay, with the time 1, I'm going on to every index and asking for the, and that's the reason how you build a DP. Take the smaller problem. Okay, I have only, let's say, time 1. For time 1, I have to go on to every index and ask him. For time 2, I have to go on every pair and ask him. But I can't go on every pair. Oh, I'll use a DP instead, which means this stuff will make sure that you are counting and grabbing the answer, maximum answer for every pair possible. Cool. Now, for some T, I'm going on to every index. For every index, I just wanted the maximum sum it can get. Either I can remove it, which means either I cannot take it, which means either I will not take that index, or if I take it, the impact which he will give at time T will be nums of 1 of I. Like when I say I minus 1, I actually mean the indexing is 1 base, so please put it like this as well. So, okay, it is I minus 1 plus T into nums of 2 into I minus 1. Now why T into? Because you know at every time T, nums of 2 is keep on adding on nums of 1. But okay, it is for time T. What if the time T is not even there, which means my time T is just 1 second, so it would not be there. But I will simply be asking for the previous, because ultimately I'm just storing the maximum as I'm keep on going forward. As I'm keep on going forward in I, I'm tracking my maximum itself. So I just need to make sure, okay, I'm tracking the maximum itself in my DP of I comma T, so that I can actually go on and say, okay, up till this point, up till the ith point, if I have T seconds, it is the maximum sum I could have given to you, so that I can use that here itself. Which means here you saw that I had my sum if I have chosen the ith element. If I have chosen the ith element, now the indexing remaining is from I minus 1, and also 1 second is gone, so I have to go and ask for the T minus 1 seconds for it. With this, we got to know we will simply go on, and for sure you might ask, okay, Aryan, why not binary search on this T? You cannot do a binary search on this T. Why? Because for sure you need to know a T minus 1. It is not a T by 2, it is a T minus 1. So for sure you have to go in linearly in time for this T. And for this T, for sure, you know one thing, you have to go linearly on I as well. So we could have done a binary search here, but we could not do, because we know, because I have to go and access a T minus 1. So if I want a T minus 1, a T minus 1 should be there. If it needs to be there, I have to go on linearly. So for sure, our O of n square part will come in picture. Here itself, we can apply a binary search, but God knows, who cares, because we don't, because for sure, our already O of n square has been already computed earlier. Now let's quickly have a look at the code. It's pretty simple and obvious as what we have seen above. Simply getting my n is the size, because we know the time actually can be n, and for sure my size is also n. Getting the sum of my first nums of 1, getting the sum of my nums of 2. Now if I have got the sum, I'll simply ask, initially if the nums of one sum is actually already less than equal to x, simply return the 0, which is no time required at all. But if I have a time, then I can simply say, okay, I know one thing, I need to sort my nums of 2 down, because I know one thing, I will iterate on this indexes, but I will iterate in the order that my nums of 2, my smaller nums of 2 should be occurring first, right? So I'll simply push in my vector of I, I'll simply make a pair of nums of 2 of I and nums of 1 of I, and I'll simply sort this vector so that it's sorted on the basis of nums of 2 of I. Right, now when it is sorted on the basis of nums of 2 of I actually can initialize my DP with the nums of 0, saying, okay, it is I, it is a T, and both I and T are maximum till n. Right now, okay, when we have got this stuff so far, now we know one thing, we have to go on at every T, we have to go on every T. For every T, I have to go on at every I. Same condition as you saw, DP of I comma T is DP of I minus 1 comma T, and it is that first, which is actually nums of 1, because nums of, sorry, it's actually nums of 2 of I into T plus nums of 1 of I plus dp of I minus 1 comma t minus 1 as the condition which we saw for dp. Ultimately, if we have got this, now we actually go on to every of my t, getting my total sum. It's actually what? Total sum for this time, the total sum, it can be nums2 sum into t plus nums1 sum. As we have seen earlier also, it is nums1 sum plus t into nums2 sum, right? I simply subtract, as we saw, why we'll subtract a dp of n comma t. I'll simply subtract this from my total sum. If it is less than equal to x, simply return that t because it's the minimum time, while if it is not, simply return a minus 1 in the end. And that's how you can simply get this solved. Again, I am saying it's a very, very hard question. Only 42, 44 people were able to solve it. So at any point of time, if you think some intuition was not clear or maybe you missed something, I'll highly recommend just go and have a look again, because it's already 1:30 a.m. in the night. Maybe your brain would not work, but if not, then I'll highly recommend, please go and watch this in the morning itself again. You will actually like it. But yeah, if the folks still watching in have liked it, can we please smash that like button to 90 likes? Just 5 more, that would be super, super, super great and cool. We would be ending soon. That was so much helpful. These people are still watching at 1:30 a.m. Damn. I know, I don't know how my neighbors would react, but whew. Let's go. ओहो, विपिन पाल जी यहाँ पर हैं. हेलो विपिन पाल जी, क्या बात है. स्ट्रीम रात में. उफ उफ. Similar to fourth question, it will get asked in interviews. I don't think so at all. It would be asked. Now thinking, if it is asked, I don't think firstly it would be asked like this, but if it is asked, it would be asked maybe in coordination or no more company I can think of. Direct AI or tower research, nah. Coordination, yeah, coordination maybe, but I don't think, because it's actually very hard, because to think this problem in a memoized way, it's next to impossible or maybe very hard. You can only think of this problem in a bottom approach, and many people don't understand bottom up DP. That's the biggest problem for beginners. So as a beginner, it will be very hard to build intuition on the bottom DP. That's the reason I specifically mentioned, for building, you should always, as you go forward in DP, just try to build on bottom approaches as well. Just try by yourself, try to build a recursive solution for it and try to memorize it. You will see, you will try on for hours and hours, and it will have many conditions to build a top-down DP for it, because the order is very important in this question. The order of T, order of I, it's very important. For I, you need to make sure that, okay, your I is traversed in from minimum nums of 2i to maximum nums of 2i. That's the reason. The ordering part can actually become difficult. But yeah, able to solve the only first question. What should I do? See, if it was your first question, Adi, then college में TCS भी नहीं आती, coordination. No worries, Yash. See, off campus is always an option, so never lose hopes. We are together. It was my first contest on the Leetcode today. But yeah, the folks are watching in, can we please smash that like button? We'll actually be ending the stream soon, because I actually need to sleep and make video for today's daily question also, and also for the live and also for the contest. Cool. Daily one virtual contest for practicing OA and only absolve one question. Only absolve one question. Can you should anything which is helpful for OA? How you prepare for interviews? See, yes, absolving only one. See, Leetcode only has 4 questions and all the questions are data structure based. So I'll highly recommend to upsolve all the 4 questions provided fourth question's number of submissions are more than equal to 500, which means more than 500 people were able to submit that, get it accepted. So please try it and get it solved as well, because then the fourth one will actually be easy one. If not, if it's around 100, 200 or 300, then you can just skip the fourth question, because it will be very hard. As this question, it's actually very hard question. The number of submissions are actually 44 only. So it's not that okay, it's hard. It's actually hard to build the intuition entirely, which means from very start to very end, it's very hard to build the entire stuff. This entire stuff, it's very hard to build. So that's the reason that the number of submissions are less. After understanding it, it can become easy, but yeah, for sure it's actually hard in the beginning. Cool. Certain work as an intern right now. I'm in 6th semester. Can you guide for Faang? Certain work as an intern right now. I'm in 6th semester. Can you guide for Faang? Simply do more coding. See, all the big MNCs are just concerned about coding, coding, and coding. Like everyone is concerned just about coding. So be good at coding. That's pretty much it. But yeah, for the folks who are in 6th semester and stuff, please also try, code forces and stuff, because if you have time, then please give code forces also. That will be super, super, super helpful. Is CP and SI to crack big product based companies, or doing only DSA lead coding can get me that? Please tell bhaiya. See, CP is not required firstly, but for ad hoc problems you will not be able to get good at it if you will do only lead code. See, when you say lead code, what maximum you could do is you could give one contest in a week and could do a daily problem. That one contest is just giving 3 to 4 hours in 1 week for one contest, and a daily question is just 1 hour, which means you are giving 1 hour every day only, and also you are just giving one day, or like not even 1 day, just 4 to 5 hours to one contest in a week. That's so much less. Now, when I say lead coding, I actually mean give virtual contest, at least solve 8 to 9 problems apart from, like, either you can solve 8 to 9 problems of our sheet. Let's say, see, when I say sheet, you can solve any sheet whatsoever you want, but please solve it ritually. You can follow the DSA 169 sheet also. That's super more than sufficient to actually wrap up everything in as short time as possible. But if not, you can follow any other sheet as well. But yeah, apart from sheet, practicing is the biggest point. When I say practicing, I actually mean giving virtual contest. Even, see, if you are in college, I know I have been in college, give one virtual contest daily and absolve that for sure. When I say absolve, I told you previously also, solving one problem for sure, no matter what. If you are able to solve 3 problems, then solve the 4th problem. But if you are able to solve 2 problems, then for the 3rd problem, solve. For the 4th one, check if the number of submissions are more than 500, solve it. If not, then don't solve it, or maybe you can skip to solve it, because if the submissions are less, that problem is actually hard. If it's actually hard, so there's no point to solve that directly. It won't help you that much. For example, the problem right here, you solve it, it's good, but you watch the video, it's good, but there's a high chance if the similar problem came again, you won't be able to solve it directly, or maybe it will be very hard to solve it, because it's actually a very hard. So basically, we actually grow like this. We don't grow like this. So for sure, if the problem is very hard above your existing level, you won't be able to recall or solve it back, or even you won't be able to have a courage to have it solved. So go incrementally, but please make sure to give more contests. If you are doing lead code, please do rigorously. Not do it like, I'm not saying just give one, just solve one problem daily and just give it one contest in a week. That's not it. Give more virtual contests, solve more problems. That's how you will be able to say that, okay, Leetcode is sufficient. If not, if you actually want the actual real life contest, you can just go and do Codeforces or CodeChef also. That will actually be super helpful. But yeah, that's pretty much late. Let's end the stream. Codeforces only, it won't help. Many people in our college did this mistake. If you are doing only Codeforces, that would not help at all. With Codeforces, Leetcode is prime, like prime. If you are very good, which means if you are half a way in expert or more than that, okay, you can skip Leetcode, because for sure to reach half a way at expert, it's actually required that you must be knowing everything: binary search, DP, and also a bit of Fenwick and segment trees. So for sure, I might assume that, okay, your DSA is already good, but again, if you are, let's say, in pupil or maybe specialist, Leetcode is prime, the must. That's a mistake which many students from our college did. They just did Codeforces because it's actually fun. Codeforces are actually fun, like actually fun. Like that's the prime reason for people to do CodeChef and Codeforces is the fun part. It's actually super fun. Just try it out. It's fun. It's actually fun. But still, for interviews, please do Leetcode because it's standardly asked like this. I will just simply see in a Codeforces round, except in a div 4 rounds. Usually, what happens is a div 2 and a div 1. Sorry, a div 2 and a div 3. In a div, I don't remember if a div 4 round still happens or not, but yeah, if in a div 4 round or in a div 3 rounds, div 4 happens. No, right? Div 3 happens only, right? No worries. In a div 3 round, you can encounter a problem of, let's say, graph saying just do a simple DFSing graph and you will be solving it. But that's a div 3 round and that's the rarest problem asked. So that's the reason Codeforces started at div 3 rounds. If you want to have it, do also div 3 rounds to actually make that work. But Leetcode, I'd highly recommend, because it's actually very important to do Leetcode, because the problems are straightforwardly asked like this. The problem you saw, the linked list problem, it can be asked in an interview simply, but in a Codeforces round, you will never see that problem. For example, the problem number 3 or 4, you could see that in Codeforces, but problem number 2, you would never see. Problem number 2 of the last contest or problem number 3 of the last contest, you will never see. So that's how you will see, okay, there are some problems which are specifically DSA based, you will see in Leetcode. But there are some problems which are DSA plus logical plus mathematical. You will see in Leetcode also and Codeforces also. Some problems having more mathematical thing, or maybe like needing fast implementation of ad hoc stuff, let's say simple binary search or simple array or simple DP. Like when I say simple DP, I mean a 1D DP. When I say a simple binary search, I mean a simple binary search with a simple if possible condition. So that's how you can simply get those questions in actual Codeforces round. So that's a big debate about Codeforces and Leetcode. I have told exactly fun. How fun? What does it mean? I didn't get it. You mean as a hobby? See, fun as in for the programming part. When I say fun, you'll actually have fun trying to build a solution out of it. You will have actual competition. See, how we used to have it was, like, we used to have me, my friends, we actually used to give, everyone used to give. So we used to have a kind of competition and then we used to discuss. So it was a fun for us. Okay, it's a fun activity, fun competition, fun game. It's not, okay, primarily important. If I will not do it, I will actually get, it's actually, see, it's a reward kind of stuff. If I will do it, I will get the ranks, which actually will help me in my resume itself. But apart from that, what I can actually also get is something as being good at programming. That, see, if the rating is decreased, if you are very much concerned about rating, it can't be fun. But if you just have it as a hobby, or maybe just do it for your good purpose, if you want to get good at programming, get good at basic CP stuff, it will be helpful. And just saying, okay, I will just think of, see how actually it's a fun. There will be a stage when you will do programming as you are sleeping. You're like, okay, I just look at look the problem. Okay, what's the problem? Then I'm basically thinking of this. I slept. I wake up in the morning. I looked at the problem again. I'm sleeping halfway, but I'm still thinking it. So basically, it will just simply keep on happening. Okay, let's end the stream. I hope that you guys got it. The battery is dead. We have been more than 2 hours. Cool. Bye bye. Thank you so much. Goodbye. Bye bye. Thank you so much. Bye bye. Bye bye.